Hello, my name is Preethi. I am working as an assistant professor, the Department of EEE in SNS College of Engineering. Today, we are going to see renewable energy sources, Unit 2 wind energy, Topic 3 components and working of wind power plant. So let's see the components of the wind turbine. So here we can say that we'll be having a different components in the wind turbine. So the basic things are, we can say here the gearbox, generator type of, we'll be having different types of generators like a double fed induction generator, wound round IG, etc. And nacelle, towers, control unit, anemometer, pitch mechanism, transformer, wind vane will be having a different types of components in the wind turbine. So we know that the basic principle of wind energy is that it is going to convert the mechanical energy into an electrical energy. So the gearbox connects the low speed shaft to the high speed shaft. It increases the rotational speeds about 30 to 60 rotations per minute to about 1500 to 1800 RPM. So the rotational speed required by most generators to produce the electricity. Then we are going to talk about the types of generators. So here we are going to focus on two different types. The first one is called as the wound rotor induction generator, and next one is called as the doubly fed induction generator. But normally the most commonly used will be that DFIG, doubly fed induction generator, the efficient over a wide range of the wind speeds. And then you can see the nacelle part. The nacelle houses all the major components of a modern wind energy conversion system except the rotor. The nacelle sits the top of the tower. The nacelle does not carry any load and it is not a structural member. And next we are going to focus on the towers. The towers are generally made up of a galvanized steel, and the tower supports the nacelle and transmits a static and dynamic forces and moments to the foundation. For modern turbines, a tower is the most expensive part. And next we are going to focus on the control unit. The control unit, the main purpose is to limit the power exerted at the high wind speeds, nothing but above the rated speed, and to start the turbine below the speed. So the high speeds typically happen only for a short time. However, if they are not controlled, they will damage the drivetrain, gearbox as well as the generator. And we are going to focus on the next part is called as the anemometer. It measures the wind speed and transmits the wind speed data to the controller. So the controller starts up the machine and it shuts off the machine. It is about 8 to 16 miles per hour. It starts up the machine about 8 to 16 miles per hour and shut off the machine about 55 mph. So the next one is called as a pitch mechanism. Pitch mechanism, you can see it here. It gears housed in the hub or activated electrically or pneumatically. We can say like this. The blades are turned out of the wind to control the rotor speed and keep the rotor from turning in winds that are too high to produce the electricity. And next one we can call it as transformer. The power from generator goes to a transformer which converts the electricity from low voltage around 480 volt to the appropriate voltage for transmission. Typically we can say 33 kV. So these are the different components of the wind turbine. So these things we have seen about the rotor, the drivetrain, electrical control mechanism, supporting structure, tower, nacelle, etc. And the working process overview. Let's see how it is going to work. The wind turbine turns the wind energy into the electricity. So using the aerodynamic force from the rotor blades, which works like an airplane wing or helicopter rotor blade. When wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air pressure across the two sides of the blade creates both the lift and drag. So the force of the lift is stronger than the drag, and this causes the rotor to spin. The rotor connects to generator either directly or through a shaft. and a series of your gears that speed the rotation and allow for a physically smaller generator. So here we can see capturing the wind energy and to mechanical energy conversion. The last one is called as a transmission and integration. So these points are highly important when you go for the working process overview. So let's see the principles of the wind power plant. So just now we have seen that the wind turbine turns into the wind energy into an electricity. So with the help of wind capture, rotor blades, rotational motors, generators plays an important role, and electricity generation, power conditioning, and transmission and distribution, and is going to connect with the grid connection. So all the things are nothing but a principle of the wind power plant. So what are the factors affecting the wind power generation? So we can talk about the direction of the wind and the speed of the wind and size of turbine and its efficiency and site selection and maintenance, operational factors, wind resource assessment. These are the various factors affecting the wind power generation. So we all know about the merits of wind power plant because it's a clean and renewable energy source and reduction of the greenhouse gas emissions and economic benefits for the local communities. These are the various advantages of wind power plant. So these are the various wind power plants in India. So Muppandal Wind Farm and Anandpur Wind Park, and top states which installed wind power capacity will be in Tamil Nadu, Gujarat, Maharashtra, Rajasthan, Karnataka, Madhya Pradesh, Andhra Pradesh, Telangana, and Kerala, and installed capacity is given in this slide. These are the various wind power plants in India. So, my dear students, today in this session, we have seen about the components and working of the wind turbine. So it's a very, very easy concept. The wind turbine turns into wind energy to electricity using the aerodynamic force from the rotor blades, which works like an aeroplane or helicopter blade. Just think about this idea. It is very easy for you to write in the examination. Yeah. What is the primary source of energy used in wind power plants? Please let me know your answer. And describe you please tell me the basic principle behind the operation of your wind turbine. So I have referred Joshua Yanast and Chatan Singh Solanki for this video. And thank you for your attention. Thank you, students.